Hello everyone. So now we are going to discuss BGP attributes. So if you remember in our previous labs we are doing OSPF, EIGRP. So in that one we are using as a metric. If we want to select the best path we are using as a metric or cos. We are using OSPF use the cos and EIGRP is using the K value K1, K3 we are saying. Same thing like that we have here attributes. In the BGP we have different attributes, so depending upon that attributes we can manipulate the traffic. Like in the OSPF we are using the metric, that is cos and the K values. Same like that we have here attributes. So what are the different attributes we are going to get? So this is very important. BGP attribute concept is very important. You are going to get maybe 5 to 6 questions in the interview about the BGP attributes. So first point what we will say, with the help of BGP attribute we can manipulate the traffic. Same like in the OSPF EIGRP we are using metric. Example, I have one router here, okay. I have another router here. Imagine this is R1 and this is R2. This is connected like this way, and here I have R3. This is connected this way. And you imagine you have route here 1.1.1 and here also you have route 1.1.1. So this R1 is getting the same route from the two different locations, from R2 and R3. So in the routing table which they are going to install, they are going to install the route 1.1.1 from this neighbor or from this neighbor. We can manipulate this. Maybe he can use this one, not this one, or maybe they can use this one, not this one. They cannot install both because in the BGP will not do the load balancing. BGP will not do the load balancing. BGP is having the list of attribute. They will check that attributes, depending upon that condition they will install this route or maybe this route. So we are going to see that one. Now just we need to remember, like in other routing protocol we have the metric. Same like that metric is nothing but here we are using as attributes. We have different attributes. With that attributes BGP is going to look the best path and they are going to install in the routing table. So what we can say, BGP select the best path based upon the list of attribute. BGP attribute used to select the best path. BGP has 0 to 14 attribute for Cisco and 1 to 14 attribute for other vendors. So BGP is having the 0 to 14 attributes for Cisco and BGP has 1 to 14 attributes for other vendors. BGP is not using metric as we are using in the OSPF or EIGRP. Here they are using the attributes. So we are going to check what is attributes and how they can work. So this is important. We need to remember this one. BGP have 4 main types of attribute. We need to remember this one. BGP has 4 main types of attribute. First one is well-known mandatory. Second one is well-known discretionary. Third one is optional transitive. Fourth one is optional non-transitive. So this one we need to remember. In an interview they will ask you, so we need to define this one. Now we are going to this inside this one detail. We are going to discuss this all in detail. So first thing we are saying well-known mandatory. So what is well-known mandatory means? This must appear in all the updates. This attribute must appear in every update message. Okay, as the name is suggesting, this is mandatory. This should be present in the all BGP. This is going to use. So must be recognized and supported by all BGP speaker. And if this attribute is missing, then we will have the notification message and error message will generate and they will close the BGP session. So if we don't have this attribute, then BGP will not form. And what is this attribute means? AS path, next hop address, origin. These are the 3 attributes belongs to well-known mandatory. So just you need to remember, well-known mandatory means that should be mandatory for all the BGP routers. And here we will have this attributes must appear in all the update message. And this must be recognized by all routers and also supported by all routers. And if we have missing anything, then we will have the notification and BGP connection will close. And these are the attributes, that is well-known mandatory. Actually this divided into big chart. Let me show you. BGP attribute is divided into different types. Just now what we told, we have well-known, optional. In well-known again we have mandatory and discretionary, and in the optional we have transitive and we have non-transitive. So we have two different types. Okay, and again in the mandatory we have AS path, next hop, origin. In the origin we have IE question mark, and here in the discretionary we have local preference, atomic aggregator, and here in the transitive we have aggregator and community, and in the non-transitive we have MED, originator, cluster ID. So we are going to see this. So what we are saying, well-known discretionary. Here we told this is well-known mandatory. So now we are looking this one. So here what we can say, must be recognized and supported by all BGP speaker. This first point is same for the well-known mandatory and well-known discretionary. May or may not appear in every BGP update. This point is different. Here what we are saying well-known, here we are saying this should be appear in every update message, but here may be or may not be appear in the BGP update message and does not to be included in every BGP update message. And well-known discretionary attributes are the local preference, atomic aggregate. Then we have the optional transitive. In this one may or may not be supported by all BGP neighbor. This is optional and will be passed on if not recognized by the receiver. Even it is not recognized, they will pass to other BGP peer. And what we will have in this one, aggregator and community. And then we have the optional non-transitive. This may or may not be supported by all BGP neighbor, and here they will not required to pass on it, they can ignore. Here they are passing, even the router is not understanding, they are passing to the other guys, but here they will, if they will not understand, they will ignore that one. And the attribute should be ignored and not passed to the other peer. And here if we see what we have, MED, we have the originator ID, cluster list. So these are the BGP attributes. In this one again we divided. This one what we are saying, we have the category. This we need to remember. The BGP attribute is well known and optional. In well known again two type, in optional again two type. In this one again we have. So just we need to remember this. And here this is the list. Original one we have originate. Origin we have, that is known as well-known mandatory. AS path we have, that is well-known mandatory. Next hop we have well-known mandatory, and we have multi-exit. This is MED we are calling, that is optional non-transitive. Local preference we have well-known discretionary. We have atomic aggregate, that is well-known discretionary. Aggregator, community, originator ID, cluster ID, these all are there. What we need to remember, this chart, if we remember this chart, that is sufficient, because they are going to ask this chart in exam. In exam also you will get these types of question, as also in the interview. And after that we need to remember this box. This is very important, this box. So this is priority base. Before going to this box, just I am saying BGP best path selection. So how BGP is going to select the best path? He is going to select the best path depending upon the attribute. Like if we remember the IGP, interior gateway protocol, like RIP, EIGRP, OSPF, how they are selecting best path depending upon the low metric. They will check who is having the low cost, who is having the what we can say K value and less number of routers in the RIP case. But here for the BGP they are going to check the attribute. If you remember in RIP, when we are doing the RIP, we told lowest hop count, OSPF lowest cost, and EIGRP we are saying high bandwidth and low delay, that is K value. Same like that here, how BGP is going to select the best path with the list of attributes. So they are going to check with the attributes. So this are the attribute. This is the in the sequence. We need to remember this in the sequence. So first they will give priority to the weight. Second, they will give the priority to the local preference. Third will be originate local, and then AS path short and origin code lowest. So this one, what I am saying, This all are available here. If you see here, this is the weight. If you see, this is the weight. So this will be appear here. Local preference, MED, and the path and originate code. So this will be here. We can modify this number. Example, we have 0 here. We can change, we can increase, we can modify this number. Depending upon that one, our route will change. Now first we need to remember, we have this 11. So BGP is going to check first one weight. If whoever is having the highest weight, that route is going to install in the routing table. Imagine if you are getting the route. Example, let me take my blackboard. Imagine you have, this is your router R1. You have another router R2, R3, and you have connectivity from this way. And you are having the same route here. Example, you have 2.2.2.2. Here also you have 2.2.2.2. So this R1 is getting this route from two way, from here also and from here also. So if you increase the weight for this route, so this will come in the routing table. If you increase this weight, then this route will come in the routing table. So first they will check the weight. Whoever weight is having the highest weight, they are going to install that one. If both route is having the same weight, then they will skip this one. They will look the second thing, that they are going to look the local preference. If local preference, whoever is having the highest value, they are going to take that one. If both local preference also same, then they will look for the originate local. Who is the local? Local means, like we are saying, the 0.0.0, the next hop. So next hop, whoever is having the 0.0.0, he is going to give that one as a preference. Example, if we have both route is having same, then again they will check the AS path, shortest path. So where we are getting the short AS. If you see here, we are getting here AS, 2 AS we have here, 1 and 3, total 2. So where we are getting shortest AS, they are going to select that route. If we are having both the sides same AS, then they will look for originate code lowest. If they are having same, then they will look for the other one. The other one will be MED. If whoever is having low MED, he is going to look that one. MED is nothing but here you will have the number. So by default we have 0. If we change here any different number, so they will check whoever is having low number, he will select that one. Imagine both are having same number, then they will look the eBGP over iBGP. If this also match, then they will check the shortest path for the iBGP over the BGP next hop. If both are same, then they will check who is having the old path. If both are old, then they will check who is having the router ID, lowest router ID. If both are having the same router ID, they will check the neighbor IP. But this we will not do. Generally in the production network, we are doing from 1 to 6. We are modifying 1 to 6, because if you are saying oldest path, so maybe we cannot say the route I am getting from the oldest path, so delete the configuration and redo the configuration, so this path become new. I can get the route from different place, or change your router ID because your router ID is low, so I am getting route from you, I need to get the route from other guy, so you reduce the router ID. We cannot say that one, right? That's why we will not do this in the production network. We will do till 1 to 6. So we are going to see what is what. Just I give you overview. So first thing I am saying the weight. First thing what we are saying first thing is a weight. And whoever is having the highest weight, that guy, that value, that route is going to go in the routing table. So let's see what is weight. Weight is a first BGP attribute in the list. It is a Cisco proprietary. It will work only in the Cisco router. Weight is local, only local on the router. Local significant. It will not go any other router. It is inside only router. Weight is not exchanged between the BGP router. In the BGP router, they are not going to exchange the weight. Weight never advertised to other router. The path with the highest weight is preferred. And weight for the router originate on the local router will be 3276. If the route we are getting from the same router, then our weight will be 32768 by default. And weight is 0 for all other router. If we are getting the route from different router, then our weight will be 0. Okay, so this is the weight. After that we can do weight lab, so we will have more idea, but let's discuss the other attributes also. Weight lab we will do in our next class. So if we go for the other attributes, like just now we discussed path selection, right? How BGP is selecting the path, he is selecting with the attributes. First, just now we discussed, first he will check the weight. If weight is same, then they will go for local preference. Local preference is the second BGP attribute. Local preference between the autonomous system exchange, the IBGP. Local preference is also a value. By default it is 100. If we see here, nothing is mentioned here. By default we will have 100 local preference. Here also not there. So local preference by default we will have 100. Whoever is having the higher local preference, they are going to select that one. So first they will check the weight. If both route are having the same weight, they will check the local preference. Whoever is having the highest local preference value, that route is going to prefer. After that we will have the originate. Originate is nothing but, this is a third attribute, BGP attribute. And what is originate means, if we are having the local route, if we are having the local means in the same router we are having that route, then we will have next hop as 0.0.0. So they are going to prefer, if that route is getting from our same router, they are going to prefer that one. Means I am saying, if I am getting this next hop, imagine if I am getting 1.1.1 from different network, maybe from here also, from here also, from here also. So which one is going to prefer? The next hop as 0.0.0, that is going to prefer. That is known as originate. Originate, they are going to prefer the local router originate. So 0.0.0 means our own route that he is going to prefer. And then we have the AS path length. So AS path, if you see this one, I am saying this here, I have only one AS. If I want to go to this network also, I have only one AS. Imagine I have like here, imagine I want to go to 1.1.1. I am getting 1.1.1 from all this network. Okay, from here all I am getting 1.1.1. Imagine that one. So they will check the AS. If you see AS is 3, 2, means we have only one AS here, but here if you see we have 2 AS. Here we have 2 AS. So they will check where we have the less AS. They are going to select that path. So what we can say, prefer the path with the shortest AS. So wherever we have the less AS, example less means like 1, 2, 3. Here I have 3. Here if you see we have 5 AS. 1, 2, 3, 4, 5. Don't see this number. Count how many we have. 1 here, again 1, again 1, again 1. So total I have 5. So what router is thinking, if I want to go, I need to cross the 5 AS. So if I am getting the same route from the 3 AS, after crossing 3 router, I will get this one. So why I should cross the 5 router? I will cross only 3 and I will get that one. So this router will prefer the shortest one. So if we want to manipulate, we can manipulate the AS path length also. In the lab we are going to see that one. So we can manipulate, so the router will think, okay, this route I am getting after 3 AS, and that route, this same route I am getting after 5 AS. So I will prefer this one, not that one. Like that we can play with the router. And then after that we have origin code. Origin code is nothing but this one. If you see here, we have origin code, we have I, we will have E, and we will have the question mark. I means IGP. Like if we advertise our, what we can say, with the network command. If we advertise with the network command, example, if I go here, if you see here, this one, we are getting this all are coming with I. I means this all are coming with the network command. They advertise this with a network command. That's why we are getting this I. If someone advertise with a redistribution, then we will have the question mark. Question mark is nothing but redistribution. We can say incomplete, but this is not a problem. Even if you get the question mark here, that is no problem. Question mark, when we see, we will say someone redistribute the route, so we are getting the question mark. So it is not a problem, just these routes are coming from the redistribution and the other routes are coming from the network. So when you are having both, they are going to prefer the network command. Whoever, what I want to say, if the two routes are coming, one is coming from the redistribution and one is coming from the network command, one one advertise with the network command, one advertise with the redistribution. So they will prefer the network command one, not the redistribution one. And this eBGP is a very old protocol, no one is using, so you will not see this in the production network. Sometime you will see I, or you will see the question mark. Even if you see question mark, no problem, it is a valid route only, just you will get this route from the redistribution. Later we are going to do the lab, so you will have the idea about that one. And then we have MED. MED is nothing but multi-exit discriminator. This is a sixth attribute. Here also this is a number, so we can change this number by manipulating this number. We can change the route also. So here after that what we have, eBGP over IBGP. If you are getting one route from the eBGP and also IBGP, so which one he is going to prefer? He is going to prefer the eBGP over the IBGP. So imagine you are getting the same route 1.1.1 from the eBGP as well as from the IBGP. So which one he is going to install in the routing table? He is going to install eBGP. Then we have the shortest IGBP path to the BGP next hop. So they are going to prefer the path within the autonomous system. If we are using the autonomous system, whatever autonomous system we are using, if we are getting the route from there, so they are going to prefer that one. If we go for oldest path, means if we are getting two route, one is newly advertised and one is olden one, so he's going to prefer the old one. And then we have the router ID. If all these parameter match, then they will check whoever is having the highest IP address, that is router ID, they are going to prefer that one. So prefer the path with the lowest BGP neighbor router ID, lowest BGP, sorry, not the highest, lowest BGP router ID. The router ID they will check, but we will not go till here. We will look only till MED only. So in the for the concept purpose, you need to remember, if all parameter is match, tie up, so they will look the router ID, whoever is having the lowest router ID, they are going to prefer that one. If router ID also same, then they will check the neighbor IP. So prefer the path with the lowest neighbor IP. Whoever is having the lowest neighbor IP, they are going to prefer that one. But if we see in the real scenario, we will manipulate till here only. Let me show you. In the real scenario, we will manipulate till number 6, I think. Let me show. Yeah, this one till MED. So in the real scenario, you will see we will increase weight and the local preference, originate local, till here we will manipulate. 7, 8, 9, 10 and 11, this is not changing in the real scenario. We will only manipulate from 1 to 6 to change the route. So in our next class, what we will do? We will do the labs. First lab we will do for the weight, how we can change the weight. Example, if you see, I am getting 2.2.2.0 from here also, from the router R2 and also from the router R3. So which one he is going to prefer? And if I want to get the route from 2.2.2 for the router 2, how I can do, what I can do? Here same thing, when we configure, if you see, we are getting the route from this one. If you see here, this is a 2.2.2.2. I am having the 2.2.2 from this next hop also and from this next hop also. If you see, this star means valid, star and greater than symbol means valid and also best. So he is going to send the traffic from here, and this is the best, so he is going to install in the routing table this one. So now imagine if you don't want to get that from here, if you want to get from here, so what we can do, we can increase the weight. Now weight we have 0, so we can increase the weight. How we can increase the weight? We have some command, we can go and we can say weight 500. So when we increase, when we check, we have the weight as 500, and if you see, before this one, below one is a greater than symbol, but now greater than symbol move here. So now our traffic will get from here 13.3. So this way we are going to manipulate. So later in our next class, we are going to see that one, how we can manipulate in our next class. Okay, so this is very important attribute, you need to remember. This is very important. You are going to get 5 to 6 questions in the interview. So let me stop the recording.